Voice over Internet Protocol, VoIP, is the federative technology elected by network operators to promote competition in long-distance and local voice services. Quality of service. Quality of service in VoIP networks represents a major challenge in sharing the connectionless transmission media with other users in a predictable and quantifiable way. The current problems with VoIP are due to the public data networks being overloaded. Another real problem of VoIP is that there are too many competing standards that potentially could create havoc and prevent the development of seamless, high-performance networks. For these reasons, the only way to provide quality of service guarantees to customers is to manage globally the network's quality of service. Full text translate, unavailable for this document. Head note: for operators delivering telephony services via IP, a global monitoring system is important for ensuring quality of service. Voice over Internet Protocol, VoIP, is the federative technology elected by network operators, old and new, to promote competition in long-distance and local voice services. The successful progress of VoIP is mainly due to the development of the Internet and the liberalization of telecommunications markets. For new operators, VoIP is a way to rapidly decrease communication costs and to compete with incumbent operators. Also, as operators more frequently differentiate themselves with new services rather than prices, VoIP will permit the creation of a new range of multimedia services, including voice and data as well as video. Nevertheless, VoIP has some important limitations, such as the lack of quality of service guarantees and accessibility of the service. Quality of service is an important differentiation element for network operators as well as a metric for regulators. For VoIP networks, the quality of service evaluation is an important issue mainly because of the best effort, low quality policy of the Internet. For that reason, operators providing a telephony service based on IP technology have to set the customer's mind at rest on the level of service quality. Furthermore, the multiplication of networks, interconnections and services tends to increase the difficulty of end-to-end quality of service determination. Quality of service in VoIP networks represents a major challenge, not so much during the predictable processes of compressing the voice streams and splitting them into packets, which are mathematically predictable, but the real challenge is sharing the connectionless transmission media with other users in a predictable and quantifiable way. As soon as voice and/or video traffic reaches the IP network, it must compete with email traffic, database applications and file transfers from the Internet as well as business traffic from private to public IP networks. A common point of view is that VoIP itself does not have any real quality of service problems. The current problems with VoIP are due to public data networks, namely, the Internet, being overloaded. By comparison, most public voice circuits operate at about 30%, or even lower, average utilization, while the Internet is normally 100% utilized. The integration of quality of service guarantee mechanisms in VoIP networks, such as Resource Reservation Protocol, RSVP, or Multi-Protocol Label Switching, MPLS, will improve the intrinsic performance of networks. Nevertheless, building networks that can provide the necessary bandwidth and guaranteed delay as well as providing quality of service management are important for customer satisfaction. Another real problem of VoIP is that there are too many competing standards that potentially could create havoc and prevent the development of seamless, high-performance networks. For these reasons, the only way to provide quality of service guarantees to customers is to manage globally the network's quality of service. Important quality of service parameters. The quality of telecommunication services depends on a combination of numerous factors. The main elements are call setup quality, service availability and call quality. Call setup quality is mainly characterized by the call setup time, which is perceived by the user as the responsiveness of the service. Service availability is the reliability of the user's connection to the VoIP services. Within the broad category of call quality, two major factors contribute to the overall quality of service experience: end-to-end delay, which primarily impacts the interactivity of a conversation, and end-to-end speech quality, which is the one-way speech quality as perceived in a non-interactive situation. One of the most important quality of service factors in voice transmissions for VoIP is the end-to-end delay perceived by the users. In order to have a normal conversation over a network, this delay should be kept almost constant and below a defined bound. If the end-to-end delay is too high, an interactive communication is difficult or impossible. Speech quality is generally characterized by comparative subjective ratings, mean opinion scores, generated in controlled human listening tests. For that reason, the MOS scores are subjective. The listening quality scale most frequently used by ITT and recommended by Typhon, ETSI's VoIP project, has 4 levels of classification. The advantage of such a classification is that it allows easy interpretation of the results. The 4 classes of quality of service are defined as the following: Best, an IP telephony service that has the potential to provide a user experience similar to PSTN or even better. High, an IP telephony service that can potentially provide a user experience similar to PSTN. Medium, an IP telephony service that can potentially provide a user experience similar to common wireless mobile telephony services. Best effort, this type of service will provide a usable communication but with significantly impaired speech quality. End-to-end delays are likely to impact the overall conversational interactivity, and no upper bound on delays is required. The perceived voice quality will be less than, for example, GSM full rate. Quality of service aspects in VoIP not including the aspects previously cited. VoIP networks present some important particularities: jitter, which is the delay variation between packets in a stream; the introduction of different speech codecs in a single communication, called tandeming the codecs; and packet loss rate, especially in the case of grouping different frames in a single packet. Packet-switched data networks have an inherent problem: delay is usually variable. While telephone services require fixed delay transmissions, data networks cannot provide this because of their best effort policies. Different packets may have different delays because of traffic conditions, and this variation is usually known as network jitter. This variability in the delay also creates the possibility of asymmetric links, in which delays may be different in the 2 directions of the conversation. In general, the following principles apply to the tandeming of the speech encoding-decoding process. Tandeming leads to degradation in speech quality, and because speech coders are highly nonlinear, the effects of tandeming are nonlinear and difficult to predict. One effect of grouping multiple speech frames into a single IP packet is degraded speech quality when packets are lost. When a packet is lost that contains one speech frame, the effect will be much less than the effect of losing several adjacent speech frames when a packet is lost that contains multiple speech frames. Quality of service management should be global because VoIP services include the ability for customers to call PSTN or mobile subscribers. Therefore, the customer perception should include the global quality of service of both networks and the interconnection. For global quality of service management, all information from the VoIP and circuit-switched network has to be taken into account. Quality of service measurement methods. 2 complementary methods can be used for quality of service evaluation: simulation-based quality of service measurement with detailed measurements on test calls, and real-time quality of service monitoring with non-intrusive access to the network. Figure 1. Simulation-based quality of service measurement involves the generation of performance statistics based on measurements realized by simulations on the subscriber interface. Such quality of service measurements performed at the subscriber interface include detailed measurements of call quality, call setup quality and availability. End-to-end tests are accomplished on the analyzed network by generating additional, non-disturbing traffic. Speech quality measurement is one of the most frequently used services in telecommunications, and speech transmission impairments are interpreted by customers as poor quality of service. Speech quality, therefore, is an important quality of service parameter. End-to-end speech quality evaluation is an approach that provides a meaningful and comprehensive value of quality that is relevant to end users, as opposed to a set of technical parameters. On that principle, there are three methods of testing end-to-end speech quality: subjective tests involving the opinion of panels of users, out of scope because it is a non-automatic method; subjective measurements comparison rating, such as the ITA Standard Perceived Speech Quality Measure, PSQM, and objective measurements, E-model, which includes comparison methods against a known reference, and the measurement of individual parameters, followed by the use of a transmission rating model to combine the effects of the individual parameters and predict the subjective views of users. Subjective tests have the advantage of including all parameters and providing a direct subjective view, but they take a long time to perform, are costly and are ill-suited to investigating changes in the values of many parameters because of the large numbers of combinations involved. Objective tests are more suitable for long-time quality of service measurements. The E-model includes basic parameters such as loudness rating, echo, distortion and noise to determine the quality of service level. Real-time quality of service monitoring is based on non-intrusive analysis of the call parameters. The advantage of this method is the exhaustiveness of the analyzed calls. The quality of service measurements evaluated are mainly service availability and call setup quality. Nevertheless, basic speech prediction can also be performed for VoIP networks. With the two quality of service evaluation approaches, simulation and real-time, operators can determine network parameters for quality of service degradation scenarios and correlate call routing information. Table 1. By automating quality of service management, network operators will see superior customer satisfaction and higher service availability. In conclusion, due to the actual lack of quality of service guarantee in Internet services, operators providing a telephony service based on IP technology have to perform quality of service measurements to evaluate the real-time quality of service of the network. To have a real-time perception of quality of service parameters, it is important to monitor them via a global system. This global quality of service evaluation system should analyze the real-time quality of service as well as measure detailed end-to-end quality of service parameters to have a global view.